We're going to take a look at solving some different types of problems that will involve the quadratic equation. Area problems are very common because areas are squared in nature, so their equations can often be modeled with quadratics. So we're going to take a look at the first one. We have a diagram here. We're told that the area of this is 78 square meters. We want to find the width, or the smallest side. So we're just going to take the area, which means we multiply the length times width, and we're going to say that that's equal to 78. So this is actually a quadratic, and we can put that in standard form. Now, before we jump to the quadratic formula, it might be a good idea to maybe consider factoring. And this one actually does factor factors of 78. We're going to get our 13 and 6. So we'll go back a little ways when we solve quadratics by factoring and set both of those factors equal to 0, and then we have our solutions being one possibility is x equals negative 13. Now that doesn't make any sense because we're not going to have a distance of a rectangle that's negative. So the only solution that is practical in this case would be positive 6. So that means that the side or the value of x is equal to 6 meters. So in the next one we're going to do something similar, and in this case we're going to look at the area. We're told that it's 108 square meters, and so again put this into standard form. See if you can factor it first. Many of the ones that you'll be working on are factorable, so you can go ahead and factor like this one, and we're going to end up with x equals 12 and x equals negative 9. Again, looking at these two solutions, only one of them makes sense. The negative value in terms of area or length of a side does not make sense. And so then this does say give the dimensions of the rectangle, so we would finish this by saying that the dimensions are going to be 12 by 9 or 9 and 12, and that would be the one that we're looking for here. So we're going to take a look at a couple others at the bottom of the page. So here we're not given a diagram, but we are told that we can look at the sides, and we're told that the length is 4 meters more than the width. So we'll assign the width, we'll say that that's x, then the length is 4 more, so that's x plus 4. And then we're told that the area is 60 meters. So again, similar, we want to multiply it out, distribute the x, put it in standard form, and then consider seeing if it factors. If it doesn't factor, you certainly can use the quadratic formula with that, as we've been practicing. This one does, however, factor, and we end up with factors of x equals negative 10 and x equals positive 6. Again, if we think about that, this negative 10 really does not apply as an answer. And then we'll end up giving the dimensions. The width is obviously 6 meters, and then the length is going to be 4 more, which would be 10. So that's some examples of some just straightforward area problems. We can do some that are a little bit more challenging. We'll take a look at that on the next page. So in this question, question number 7, you'll notice that we're told that we take a square and alternate, so we change it. So we have this square, and we want to know what's the area of this square originally. Now we're told that the square's length is increased by 5, so into a rectangle now. So the rectangle's length is going to be x plus 5. And then we're told that the other dimension is decreased by 2, so the rectangle's width is going to be x minus 2. And we're told that that area is 98 square inches. So we're going to multiply the length and the width of the new rectangle, and again we're going to multiply it out, distribute the two binomials, and we'll then put this in standard form, because then we can either factor it or use the quadratic formula, and in this case this happens to factor, and we can get 12 and 9, and we have two possible solutions, one of which is negative and the other one is positive. That's the one we're going to use. But notice that the question's actually asking for the area, and so then we need to finish the problem by actually giving the area of the square, which is going to be 81. So that's going to give us, and it's 81 squared inches, or inches squared. So that's a good type of problem to, again, just a little bit different, again using area. The next problem also is quite interesting, because they tell you that the shaded area is 59 square inches. So what they're saying is that this area right here is 59 inches. Now, if you remember back from your geometry days, an area that you could find this simply taking the difference of the two areas, right? So if you take the large rectangle area and subtract out the small rectangle, you'll have everything in between. So that's actually what we're going to do algebraically here, and you might have done some problems like this before, where you take one area, subtract it from the other algebraically like this, and go ahead and multiply this out. Now I'm going to save the rest of this for you to put into standard form and solve it. The completed notes, you certainly can check your notes with that a little bit later on. Those will be in the folder. And the last type of problem we'll do in class is going to be working with just consecutive numbers or odd numbers or something like that, but we call them number problems, and you can see that, for instance, the product of two positive integers is equal to 56. Now this isn't a very challenging one. You could probably come up with this just using some mental math, but we want to think about this just in some basic terms so that we can apply it to more complicated problems that we might not be able to think about. So if we're thinking about two positive integers, let x be the first integer, and then x plus 1 is going to be the integer next, because you're just going to add 1 to it. Now again, you could just then multiply these two together, these unknowns, and then you can set it equal to 0 and see if it's factorable, and in this case it is. Now the one thing we want to mention about these two solutions is that one of them is going to be negative, -8. The other one is going to be positive, +7. Now you want to consider what the question's asking. It's asking for two positive consecutive integers. And so the two that we want to look at obviously are 7 and 8. Now it turns out, interestingly enough, that if you look at the other solution and you look at a consecutive integer, -8 and then -7, that will also give you a product of 56. And so if we look at those two values, that might have also worked, except that the question wasn't asking for just any integer. It was asking for positive integers, and so we'll take a look at that one as well. If you look at the example below it, the one thing I wanted to note here is this is referring to two positive odd integers. And so odd numbers, you just have to remember that odd numbers, just like even numbers, are separated by two values. So if your first number is let's let x represent the first number, then x plus 2 is going to be the next odd number from that. And again, think of this, you pick a number like 11 and the next odd number is going to be 13. It's 2 away. So even though you know, we want to think sometimes it might seem counterintuitive that 2 is an even number, but it actually, that's how far odds are from each other. So again, I'm going to let you finish this one up, and then you can check your notes compared to the completed notes that I posted in the folder. The projectile notes are actually in the Delta Math assignment and also in the completed notes document.